So your test tomorrow is on section 7.1 to 7.5. Your review, for the most part, is just like your test, except 5 through 7, you're not going to see on your test. So if we look at numbers 1 through 4, we're just simplifying, and if necessary, we're writing our answer in simplest radical form. So if we look at number 1, we have the square root of 12x cubed over 25. The square root of 12, well, the 12 you can break down to be 4 and 3. The 4 is 2 and 2, so that gives you the two 2's that pair up. It's going to be 2 on the outside. You're also going to pull an x out because that x cubed is x times x times x. So 2 of those x's pair up, 1 comes out. You're going to be left with the 3x underneath the square root, and then the square root of 25 is just 5. So that gives you the 2x square root 3x over 5. For number 2, you have the square root of x cubed over 16. So again, this x cubed is like saying x times x times x. You have 2 x's that pair up, so 1 comes out. The one that's left over stays under, and the square root of 16 is just 4. So it's just x square root x over 4. For number 3, you have the cube root of 16x to the 4th power. That 16 is 4 and 4, but we're looking for 3 of the same number, so we're going to break it down even more to be 2 and 2. So you have 3 2's that group up. You're going to pull 1 out. 1 stays underneath. That x to the 4th power is x times x times x times x. So again, 3 of those x's group up. 1 comes out. You have left over 2x. So it's just 2x cube root 2x. For number 4, you have the 4th root of 32x to the 11th power. So this 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. You're looking for groups of 4. You have 4 2's, so you're going to pull 1 out. 1's going to stay under. Your x to the 11th power, though, you're going to take that power of 11 and divide it by 4. 4 goes into 11 2 times with a remainder of 3. So the x squared goes on the outside. The x cubed stays underneath. So it's just 2x squared times the 4th root of 2x cubed. Once again, we're skipping 5 through 7, because there is nothing on your test that asks you for the domain. We're going to move on to numbers 8 and 9, though, where we're simplifying the expressions involving rational exponents and then writing our answer using positive exponents. So with these, you don't have to worry about radicals. However, you need to think about your rules with powers. So remember, when you're multiplying two the same bases that have the same power, you add their powers. If you're dividing two bases that are the same, you're subtracting their powers. And then if you have a power raised to a power, you're multiplying those powers. So for number 8, we have x to the power of 2, y to the power of negative 3, z to the power of 1, all raised to the 1/2 power, all divided by x to this 1/2 power, y, z to the negative 1/2 power. So if we first sort of distribute that power of 1/2 to all of the terms up top, this is going to give us x to the power of 1, y to the power of negative 3 over 2, z to the power of 1/2. And this is all over x to the 1/2, y to the first, and z to the negative 1/2. If we follow our rules from here and we're working with division, you're going to have x to the first power minus the 1/2 power, which is 2 over 2 minus 1/2. Y to the negative 3 over 2 minus the first power, so 2 over 2. And z to the 1/2 minus the negative 1/2. So we're going to add your numerators, keep the denominator. This is going to give us x to the power of 1/2, y to the power of negative 5 over 2, z to the power of 2 over 2, which is 1. So if we write this using positive powers, it's just going to give us x to the power of 1/2, z over y to the 5 over 2. And again, it doesn't ask you to write it using radicals. It just asks you to write it using positive powers. So that's going to be our answer. For number 9, you have x to the 1/2 power, y to the 1/4 power, multiplied by x to the 1/4 power, y. Remember, the power on the y that's in the second set of parentheses is 1. And we're going to be adding powers if the base is the same since we're multiplying. So that's going to give us x to the power of 1/2 plus 1/4 times y to the 1/4 plus 1. Our least common denominator on the x to the power of 1/2 plus the 1/4 is 4. So that's going to be x to the power of 2/4 plus 1/4. And on the y, it's 4, so it's going to be y to the power of 1/4 plus 4/4. We add those numerators, keep it over the denominator. That's going to give us x to the power of 3 over 4, y to the power of 5 over 4. Again, only working with positive exponents, so that will be our answer. For 10 through 12, we are performing the indicated operation and simplifying. We are going to be writing our answers in simplest radical form. So for number 10, we have the square root of 12 minus the square root of 50 plus the square root of 72. We have to simplify all of these radicals first before we can combine anything. So that's square root of 12. 12 is 4 and 3. 4 is 2 and 2. Your two 2's group up, so that's going to give you 2 square root 3. That's square root of 50. You have 5 and 10. 10 is 5 and 2. Those two 5's pair up. That's going to give you 5 square root 2. And that square root 72, you have 9 and 8. 9 is 3 and 3. 8 is 2 and 4. 4 is 2 and 2. So you're going to group up the two 3's, the two 2's. That's going to give you 6 square root 2. You have like terms between the negative 5 square root 2 and the 6 square root 2. So you combine them to get 2 square root 3 minus the square root of 2, or minus 1 square root 2. It's the same thing. For number 11, you have negative 2 square root a times the square root of a minus the square root of ab to the 6th power. You should have another set of parentheses there. So we're going to distribute this in. It's going to give us negative 2 times the square root of a squared, because a times a is a squared, minus negative 2 square root a squared b to the 6th power. Your negative times negative is a positive. You're also going to simplify those two radicals. So it's going to give you negative 2 times a plus 2 times a b cubed. So this is just negative 2a plus 2ab cubed. For number 12, you have 2 square root x minus square root y times the square root of x plus the square root of y. We're going to FOIL this out. So we're going to do 2 square root x times the square root of x. It's going to give us 2 square root x squared. 2 square root x times the square root of y is positive 2 square root xy. The negative square root y times the square root of x is a negative square root xy. And then the negative square root y times the positive square root y is the negative square root y squared. Your radical cancels out the power of 2 on both the x squared and the y squared. You also have like terms between the 2xy and the negative xy. So this is going to give us 2x plus the square root of xy minus y. For your next set of questions, you are simplifying and writing your answer in simplest radical form. Remember, with these, you are rationalizing denominators. In order for you to rationalize the denominator, multiply the top and the bottom by that square root or cube root, whatever it is on the bottom of the fraction, by itself as many times as your index. If we look at example 13, you have the square root of 2 over 5. This is the same exact thing as saying the square root of 2 over the square root of 5. You cannot simplify any of those square roots, so rationalize your denominator by multiplying the top and the bottom by the square root of 5. This gives you the square root of 10 over the square root of 5 times 5, which is just 5. You cannot simplify this because that 10 is underneath the radical and that 5 is not. For number 14, you have the cube root of 2/3. Again, this is the same thing as saying the cube root of 2 over the cube root of 3. So because our index is 3, we're going to multiply the bottom by the cube root of 3 a total of 3 times. So we do the same to the top. We have the cube root on the top, all the same. So that's going to give us the cube root of 2 times 3, which is the cube root of 18, all over the cube root of 3 times 3, which is just 3. You cannot simplify this any further, so this is your answer. For number 15, you have the square root of 10y cubed over the square root of 6. Your 10 and your 6 are both underneath the square root, so you can simplify them, and the 6 would just become a 3, the 10 would become a 5. So you're really doing, you can also square root the y cubed, so be y times the square root of 5y all over the square root of 3. So now, since this is in simplest form, you can multiply the top and the bottom by the square root of 3 in order to rationalize that. And it's just going to leave you with y square root 15y all over 3. You can't simplify anything else, so that's your answer. For 16, you have the square root of 15 over 2 plus the square root of 5. For this one, you have to find your conjugate of your denominator. So keep the 2 terms, but change the sign in between them, and multiply the top and the bottom by 2 minus the square root of 5. We're going to distribute the square root of 15 in. That's going to give us 2 square root 15 minus the square root of 15 times 5, which is 3 times 5 times 5. So I just factored the 15 to be 3 times 5. This is all going to go over the 2 squared minus the square root of 5 squared, since it's a difference of squares. So this is going to simplify to be 2 square root 15 minus 5 square root 3 all over 4 minus 5, because your square root cancels out that radical. Or sorry, your square root cancels out with the power. We simplify this to be 2 square root 15 minus 5 square root 3 all over negative 1. We then simplify by just changing your signs to where you have 2 square root 15 plus, or sorry, negative 2 square root 15 plus 5 square root 3. For 17, you have negative 3 minus the square root of 18 all over negative 6. The first thing I would do is simplify that negative on that 6 by changing the sign on every term. So then you're working with 3 plus the square root of 18 over positive 6. From here, we're going to simplify the square root of 18. 18 is 3 times 6. 6 is 3 times 2. So that 3 comes out. You're working with 3 plus 3 square root 2 all over 6. Now your 3 square root 2, and 6 have common factors of 3. So we're going to simplify all of this by dividing all of those numbers by 3. And you're just going to work, or just going to have 1 plus 1 square root 2 all over 2 left over. For your last section, we're just solving, and if necessary, writing our answer in simplest radical form. For 18, we have w squared is equal to 100. For this one, to find w, we're just going to take the square root of both sides. Remember, because we're taking the radical of both sides, that is a even number, we're going to put the plus or minus in front of our answer. So this is just going to give you that w is equal to plus or minus 10. For 19, we have a minus 5 squared is equal to 4. So we're going to take the square root of both sides here. Remember that 4 becomes plus or minus 2. I'm going to just pull this over here. So this is going to give us a minus 5 is equal to plus or minus 2. We're going to separate this into 2 equations. So we have a minus 5 is equal to negative 2, and a minus 5 is equal to positive 2. Move your 5 over, add it to both sides for both of these. You're going to have that a is equal to 3, and a is equal to 7. Check them both. 3 minus 5 is -2. -2 squared, that's 4. That works. Check the 7. 7 minus 5 is 2. 2 squared is 4. That works too. So both of these are solutions. For number 20, you have the square root of m minus 1 is equal to 3. So we're going to take this, square both sides. So this gives us m minus 1 is equal to 9. You move your 1 over, add it to both sides, and you get that m is equal to 10. For 21, you have the cube root of 2x plus 9 is equal to 3. Raise each side to the third power now because your index is 3. That's going to give you 2x plus 9 is equal to 3 cubed is 27. We're going to move the 9 over by subtracting it from both sides. This gives us 2x is equal to 18. Then we're going to divide each side by the 2. And we get that x is 9. Plug it in. Simplify. The 2 times 9 is 18 plus 9 is 27. The cube root of 27 is 3. So that's definitely your answer. For 22, you have m plus 1 to the power of 1/3 is equal to 5. Your denominator on that power is 3, so you can raise each side to the third power and work with that. So this is going to cancel out your power, so you're just working with m plus 1 is equal to 5 cubed, which is 125. You subtract your 1 over, and you're just left with m is equal to 124. Again, plug it in, simplify. The cube root of 124 plus 1 is the cube root of 5, which is 5. So you're good. For 23, you have the square root of x plus 3 is equal to the square root of x plus 2 minus 1. Take both sides, square them. This is going to leave you with x minus 3 is equal to x plus 2 squared minus 2 times x plus 2 times 1 plus 1 squared. This then leaves you with x minus 3 is equal to x plus 2 minus 2 times x plus 2 plus 1. Combine your like terms with the 2 and the 1. That's x minus 3 is equal to x plus 3 minus 2 square root x plus 2. Move your x over, subtract it from both sides. Move your 3 over, subtract it from both sides. This is going to leave you with -6 is equal to -2 square root x plus 2. Next, you're going to divide each side by the -2. So this leaves you with 3 is equal to the square root of x plus 2. Get rid of the square root, square both sides. You're going to work with 9 is equal to x plus 2. So just move your 2 over, subtract it from both sides, and you get that x is equal to 7. Check this. 7 minus 3 is the square root of 4. That's 2. 7 plus 2 is 9. The square root of 9 is 3 minus 1. That's 2. That gives you a true statement. So that x is equal to 7 is your answer.